Right, because in the API, we're putting all the values into one array, which is working okay. So now I should be able to just right. So we have the mean and the upper and the lower confidence intervals. That's fine. We're pulling the data out of here, which works okay. Just check. These parameters should be the same as these three. So 0.1, 0.01, 0.07, and minus 0.04. I get that. And what? Like initialize it or something. Yeah, if anyone knows what's wrong with this, let me know. This is increasing. So what I want to do is plot all these values as you keep changing parameters. It will be plotted over time, so you can see how it changes when you for example, change the mean method from geometric to arithmetic. This one, by the way, yeah, this is wrong. Shouldn't have to then click on it again for it to return something useful. Anyway, I'm having trouble with this inserting into array. Should be pretty straightforward. The shift register, that should work. I mean, it's not even doing it even once. Back to what I'm trying to do is update this tool, which has all sorts of issues with it. So normally what I'm doing through the streams is going through, well, I got stuck on the first one, but normally I go through these tools on bionicchaos.com and try and improve them. I got stuck on the first one. Yeah, there's a lot of bugs with the other ones as well. One thing that we want to do is for these annotations instead of, so this is just, well, it's actually, yes, displaying the data, but you could scroll through the data and when you select one of those. So yeah, the scroller could have stayed there as a smaller thing. Yes, and we want to just be able to click on the table itself instead of using this index bar. And there meant to be seizures, epileptic activity in there as well. But currently I got stuck on this first tool trying to, so I have now a prototype. This is the original version that was published. One of the problems with this is that this meant to be bars. This is a confidence interval. So this is the actual mean and this is maximum and minimum confidence levels. So in here, this is a prototype version. I'm trying to plot them as upper and lower bar chart, and then you have the value. Well, actually, this value can be connected line, so then you can see. So it will be essentially a blue range, and the mean as a line in the middle. But I'm having some trouble doing that. Because when I add an extra dimension, what happens? I don't quite understand. It's a bit different from Matlab, which is a bit annoying. But what happens if I actually have this index in there? Which one? Ah, this one is running, so I have to stop. One, let me run the other one. So why did it already executed 3 times? Right, so it sounds like I need to do something else until I figure this out. It's just annoyingly just a bit different from what of how Labview works. Just a different version of it. And yeah, and on in the same tool, we were also last time we were looking at so I'm calculating entropy, right? But I'm getting this weird number, which is really, really large numbers, which I'm sure are not calibrated in Labview. So I don't know if anyone from Labview can hear me or will ever watch the video. Might leave it in the video that I edit later. This function didn't go into the maths, but it's returning some weird numbers. Some of them actually don't work at all, and some of the numbers are too large. So I was using this entropy function in Matlab, and this is actually calling a Matlab function from within Labview. But when I run this, I'm still having a bug that I don't get a return value, but I do get a figure, a Matlab figure. So if I run this script, yeah, it's actually shows a Matlab live figure. But what I really want is for me to have this on the website and be more useful is if I get it in Labview, but the return value for some reason is just the same as the input. So I'm not sure. Oh, come on. Anyway, not sure what's up with that. So I'm still trying to sort this out. It's just apparently the way I'm calling this function. So this is the entropy function input, and it needs, well, obviously the input array, and then it needs, I think the delta t, which is 1 in this case. Anyway, it works because this Matlab figure looks legit. And yeah, the numbers, if you average this, will be, what is it, 0.94, which what the entropy of this type of noise, was it Gaussian noise, should look like. But Labview gives me this type of numbers minus 760, whatever, which is, yeah, seem a bit odd. And this is the Shannon um, Shannon entropy, for which we have the equation there. So it's either something, I assume this equation is correct because they probably just copied it, some of the, one of the Labview people just copied it from some textbook, but maybe it's the implementation of it in this function, which I actually can see the source code for. This would be the different type of entropies. And Shannon one is it the, yeah, it should be the one at 0. So here should be this 0 one. Is this magic? This is just a magic number, and then what's up with that? Is this equation even correct? No. Yeah, could be. Right, so it's this. Oh, it's this. What's this function? The negative of the sum. This equation doesn't have the negative, but yeah, whatever should give the same value. Um, yes, it's power of 2, which is there, multiplied. Oh, is it this power 2? Log. What's this magic number? So it's not in the equation. Very small, but okay. I think that meant to be some sort of calibration, so maybe that number is wrong. Anyhow, I was just trying to compare it with Matlab, and yeah, Matlab seemed to be returning a more legit number. Yeah, just for me to put it on the website, I need it to be returned in this array and not in a Matlab figure. And yeah, I need to open. By the way, you can do the same in Python. You could actually see how difficult running it in Python would be. Right, that's the entropy function. Yeah, it's the way I call it because some of the calls will just return the figure, and other calls, assuming this one, will actually return the values. Entropy. What if I remove this thing? Right. I don't really need the time thing. It's starting off 6. So do need this array. The way I'm running it with two variables, so it should be it's not this one. It's that one. I'm not running it with running it, yeah, with FS. Um, right. Oh, come on. I had Empatica. So it's using this Empatica smartwatch that's recording accelerometer. Just go. This link's still working. Right. Yeah, so it's recording accelerometer electrothermal activity, so essentially how your wrist or palm is sweating or not. A PPG, which is not actually not proper PPG. Heart rate, which is pretty sure just calculated from this PPG, and temperature, which doesn't do much. It just stays body temperature most of the time. And the idea was that in red you have the seizures, and in blue you have the no seizures, and you're trying to find to classify, to distinguish between them with some sort of algorithm. Um, but what you find is, oops, just to say, what you find. So this is in a Matlab script that I have. I think in red should be the seizures, and blue is the non-seizures. But then you can see how they essentially like overlap. So actually, if you look at the entire data set, there's nothing there. So it's a very noisy, essentially noisy data set. But I haven't tried a few things which probably will be worth trying. Just one second, I need to sneeze. I haven't tried splitting the data by the different patients. I think there's 6 or something patients. Yeah, I have this Matlab script up and running somewhere. Can look at it again, but this video pretty much covers what I have done so far. Yeah, so the reds are seizures, the blue are no seizures, and you can see that on like different parameters they just like overlap one on top of the other. I should still have this in. I This should be still up and running. Yes, so if you take accelerometer, there's much more of no seizures. Um, so no seizures in blue, seizures in red. But essentially, I don't know what's. Yes, something like that could be interesting potentially, because this could be something that is happening just for one of the patients. and in that case, there's no red like seizure overlay. So maybe if you plotted that just for that patient, you could see a cluster of red and a cluster of blue separated. That's where you could probably do something with the accelerometer before seizures. The problem is that it's not seizures. There's actually no seizure data. Those are seizure. This is 20 to 80 minutes period of time before a seizure. So yeah. So you're meant to be able to do a prediction. Same for. Uh, oh, sorry. So this is blood volume pressure versus accelerometer. Uh, Maybe I plotted it incorrectly, but yeah, I tried different things. That doesn't seem to be much there. Yeah, so the idea is, yeah, you need the two separate parameters, and when you plot the data, yeah, you should be able to distinguish between them. So essentially, it will tell you that uh, heart rate is distinguishable. So it doesn't matter. You could look at it just at as yeah, you can plot it as two distributions of just the one thing, and the two distributions will be overlaid. Which I'm pretty sure, yeah, I tried as well before doing those. But yeah, in the competition itself, you're meant to be using Python, NumPy, Pandas, whatever you want. And I think they want you to also run it on their cloud. Uh, so for you to be able to make a submission, so they then assess the score, the performance of your algorithm. Um, and yeah, there's some prize money and stuff like 8K US and 5 and 3 to like first, second, and third places. So there you go. It's just that I'm pretty sure like all these numbers will just all the performances will just saturate because the data is noisy. So it will just saturate to something, and it's like running a 100-meter dash where everyone is Hussein Bolt or something. So then you essentially cannot distinguish. Like all the results will be the same. They will saturate at some point. So I'm not sure if it's even worth submitting anything, because yeah, it will be just a luck. It will be just a draw. They've already published a paper on this, which is definitely worth reading. This is with that. This is where the data is, and there was a paper as well. Right, so there's quite a lot of data from, what is it, the six patients, and you have labels. So importantly, these patients had an implant that was recording the EEG, and that's how they labeled the data. But the EEG data is not included in in this. It wasn't published, so yeah. So yeah, obviously, if there was a EEG, I would be all over all over it. But no, they just published data of this smartwatch that, yeah, it's not very great. But yes, it's worth looking at, and it's worth reading the original paper. Which I can't find the link at the moment. It's somewhere there. The competition is on this Eval AI website. I think that's where um, the GPU is running. So they want you to run your script on the server, on Eval AI server, which is, yeah, there's a Docker, like a Docker container or something that does that. So yeah, definitely like a very interesting, worth while looking at, but can't find the link. Should be links to the paper and everything. Why not just upload the paper in here? Anyway, if you have the link to that paper, let me know. And yes, if you wanna use Matlab, I can start you off with like how to load the data. Yeah, made this, pretty sure made this from scratch. Yeah, because their code was made in Python. And what else do we have? We haven't touched this fuzzy logic. Yeah, I had a video on it, but probably didn't explain it properly. And I made some changes since. Yeah, maybe touch on this one because yeah, I'm more excited about more excited about this one. It's yes, it's an example of fuzzy logic. That's the original. There's a video on it if you wanna see. Um, it's actually potentially relevant to that competition because you probably could use. I would have probably used fuzzy logic um, to try and make a prediction on detection. Well, more of a detection, but possibly a prediction. I mean, if you find something, you should be able to see it, and if you see it, well, then just use any any algorithm you like. Um, so in this case, yeah, let me know if I can improve this somehow. The idea is that you have this input signal. What's this smell? Something's burning. Hopefully it's not my GPU because it is getting quite hot. Check performance. Let's check that my GPU is not burning. It's only using a 90 watts and this, right, that's GPU alone. CPU will be using some more. What's the temperature? The temperature looks okay. No, that should be fine. So yeah, so when you select a certain signal, then it will detect it. And currently it has 0 detection error and 0 unknowns. This is an output, by the way, not an input. It looks like you can make a selection, but no, you make a selection here. So when left trapezoid. So yeah, so it's having more difficulty detecting the left trapezoid. So it's making a 12% detection error and unknowns. So if you reduce the noise, this number should go down. That takes some time. It went, yeah, all the way to 0 because there's no mistakes anymore. And if you put this number very high, it actually can't make, or would be, sometimes it's able to make a detection, but essentially 96 or so percent errors. You can put somewhere in between, so it drops to whatever, it will drop to 80. But some of the signals are easier. It's a, so this is a fuzzy logic thing that is working in the background. I can show you the, so this will be both logic, fuzzy logic. So this is it as a web app. See the HTML for it. Again, you can't edit it from here. You have to actually edit it. So if you're moving, if you're making any changes in there, it will change the HTML. But yes, there's quite a lot of limitations with this, as you can imagine. And it's this is its source code. What's this one doing? I don't actually remember what. And there's no comments. And it's calling an API, a Labview API. And yes, potentially it could call like a Matlab API or anything else. Sorry, the YouTube analytics. It's so distracting. Just had it on the screen. should get rid of it somehow. But I don't know if I need it or not. Yeah, if you go on Zoom, I'll get a notification. But I'm not sure about any messages on YouTube. Anyways, it's calling this API that is Matlab. What's the API called again? But so it's in anyone can access it. I said it multiple times before, but I'll say it again. Anyone can access this data, so you could potentially just create your own user interface or a web app, a web application. But Yes, the API is running on the same server as the website. I'm running everything locally. There's no third parties or anything, except Labview, Matlab, Python. Not yet Python, but hopefully Python soon. So this is in Matlab, and it's in what's it called again? Pattern recognition. So it's in pattern recognition, right? Uh, Right, so you can run it from. So this is what actually doing the fuzzy logic business. This business is streaming to um, making it an API, streaming to the web. And this is what this parts FS Labview actually has a toolkit. Fuzzy logic something. Yeah, fuzzy system designer. You can actually load the new file open. Yes, Biomedical parts FS and this will show you what the whole thing does, and you can even test the system this way. Anyways, this interior is very similar to the interactions I showed you, like in a Matlab script, for the different parameters, recorded from. Well, it could be anything; it doesn't really matter where the data is coming from. So yes, so you could set up your fuzzy, they called fuzzy rules. There's a lot of material on this that you can look into. This is interesting. HTML reports interesting. Um, so yeah, so this is specific for this tool. So this is a Labview thing. It's using one of National Instruments examples. And this is me doing a similar thing online. You can still see some percent there. If there's no noise level, you can see that should go. Yep, go up. It's hard to. Yeah, it's very sensitive, isn't it? So it was either. Yeah, so in some conditions will be more sensitive to noise than others. Like in this case, when noise just crossing one slightly, the hairs are jumping through the roof, even though should be able to detect. Still looks like a square to me, right? And if it's below one, it's then dropping almost to zero. Just try to figure out where this burning smell is coming from. Hopefully it's from outside and not my computers. Yeah, it's from outside. Someone's just cooking something. Yeah, please do let me know if there's any questions.